A boat is pulled into a dock by a rope attached to the bow of a boat and passing through a pulley on the dock that is 1 meter higher than the bow of the boat. If the rope is pulled in at a rate of 1 meter per second, how fast is the boat approaching the dock when it is 8 meters from the dock? So this looks to me like a right triangle Pythagorean theorem related rates problem, because there's this distance that the boat is away from the dock right here, and there's also this vertical distance where it says that the boat is passing through a pulley that is 1 meter higher than the boat. So that's telling me that vertical distance there is 1. And I care about the rate of change of how fast that horizontal is changing when the boat is 8 meters away. So if I do just a quick Pythagorean theorem to find the hypotenuse there, I could find that slanted side of that right triangle. I can quickly find that that hypotenuse will be exactly radical 65 meters. And I'll leave it like that for now. I'll simplify later if I need to. The other information they tell me in the problem is this rate, where it's saying the rope, this is the rope right here, is being pulled in at a rate of 1 meter per second. So you need to think about what that means, that this distance is getting shorter and shorter and shorter, 1 meter every second. So really what that's telling you is that the rate of change of your hypotenuse is negative 1 meters per second. It's negative because that hypotenuse is getting smaller. The boat's getting pulled in towards the shore. So I'm looking for this rate of change right here, the rate of change of whatever this side is. Now, there's some other information they actually give you here. Regardless of how close the boat gets to the dock, this distance isn't going to change. So this is always going to be 1 meter. So the rate of change here, dA dt, should be 0 because that side isn't changing at all. So the equation I can write to relate all these variables is going to be the Pythagorean theorem. A squared plus b squared equals c squared. And I'm going to start because I want to look for the rate of change of b, so I need to implicitly differentiate this equation here. So I'm going to use the chain rule for each of these, where I bring down the 2, and I multiply by the derivative of the inside function. So 2a dA dt plus 2b dB dt equals 2c dc dt. Before I make my substitutions, I like to divide everything by 2 just to make my calculations a little bit easier. So my a value is 1, and the rate of change there is 0, again because that vertical slice is constant. I'm looking when the boat is 8 meters away from the dock, and that rate of change is exactly what I'm looking for. My hypotenuse is currently radical 65, and that's changing at 1 meter per second, but it's decreasing, so I need to recognize that that's a negative rate. So this is going to go away, and I can divide both sides by 8 here to find that my rate of change, or dB dt, is negative radical 65 over 8, or if you round, it's about 1.00778 meters per second. Excuse me, negative, right? That should be a negative rate because the boat's moving closer to the dock, so that 8 meters is getting smaller and smaller as time goes on.